to get going. I've pushed all the right buttons, I hope. If I haven't, maybe something. Anyway, I would like to open tonight, firstly, with an acknowledgement that I'm here on the lands of the Mawuk-Ma'oloni tribe of San Francisco Bay Area, an unrecognized Indian nation. And this is a cultural tradition from Australia and New Zealand that I'm importing over to this very small part of the United States. And it's by no means a cure for systemic injustice, but it is a discussion starter. And tonight, our event, Society, Robots and Us, is all about starting the discussions. And I think we're having a really interesting discussion tonight. We're going to be talking about the economics of open source robotics, including both hardware and software. And we know that open source is very good for community, but is it good for commercialization? So I wanted to bring together some real experts in this area and see what they have to think, see what they have to say about it. And our guest speakers tonight are Katherine Scott from Open Robotics, Ryan Gariepy from Clearpath Robotics, who's also on the board of Open Robotics. And I meant to say as well, Katherine Scott is also on the board of Open Hardware. We will also have Jason Hampton Taylor and Kent Gilson from Haddington Dynamics, and Camilo Buscaron from Amazon Web Services Robotics, and Ken Goldberg, artist and roboticist. I'm Andra Keay. I'm the Managing Director of Silicon Valley Robotics, and I'm also a visiting scholar at Citrus and the Banatao Institute's People and Robots Lab. And when we say Citrus, it is not citrus the fruit, it is Citrus standing for the Center for Information Technology Research in the interest of society. And before we get fully rolling, I do want to let you all know that we have a couple more events coming up in the next week that are going to be fantastic. We've got our monthly Bots and Beer tomorrow night, and I know Fergs is in the audience. Fergs, who is the author of the Robot and Chisel blog, is our regular guest, and we'll have a number of show and tells. One will be an Australian sensor company, and I can't remember what some of the other show and tells are. But if you have a robot to show and tell, whether it's open source or not, then come to Bots and Beer. We do open mic, we do announcements, and we also have a monthly online robotics job fair, but the next one won't be for another 2 weeks, October the 21st. Finally, the most important event of the next week is Ada Lovelace Day on October the 13th. And we've been holding a celebration of women in technology, specifically women in robotics, every year on Ada Lovelace Day since, wow, I've been doing it for quite a long time. And the Women in Robotics organization has started to publish an annual list of women in robotics you need to know about to celebrate Ada Lovelace Day. And that list will be coming out in the morning of October the 13th. We'll also be having an incredible panel on the evening of October 13th at 6 p.m. And the speakers will be Dr. Ayana Howard, Dr. Carlotta Berry, Dr. Ariel Anders, who's at the first technical hire at Robust AI, and Angelique Taylor, who is at Facebook, as well as finishing a PhD in healthcare robotics. Now, these women are all amazing roboticists with a wealth of experience. And the moderator for the panel will be Jasmine Lawrence, who was one of our awardees last year, is currently a product manager at X, the Moonshot Factory, but is also an entrepreneur. And we like to celebrate every aspect of robotics that women are involved in. So it's going to be a really interesting discussion. But tonight itself is going to be a fantastic discussion. And the way it works is I'm going to introduce each speaker who will give us a short talk. And we might field your questions then, or we might wait till the end when we'll have general question time. Our first speaker tonight is Ryan Gariepy. He's the CTO and co-founder of Clearpath Robotics, where he drives the development of Clearpath's autonomous control software modules while guiding the continued expansion of Clearpath's research platform lines and custom industrial automation solutions. And Gariepy is also on the board of Open Robotics. So over to you, Ryan.
Thank you very much. This is just the obligatory screen share test. Can you see it?
Yes, indeed.
Excellent. Well, welcome everyone, and thanks for coming out this either early evening or late evening, depending on where you are. As Andra said, I'm the CTO and co-founder of Clearpath Robotics and Auto Motors, as well as on the board of the Open Source Robotics Foundation. Just as a very, very brief introduction, because it's admittedly confusing. If I look on under the Clearpath brand, we have Clearpath Robotics, which is what we consider to be the largest and most successful robotics research solution provider in the world of all sorts of things, not just the black and yellow robots that are most familiar to many, as well as Auto Motors, which is a global leader in autonomous material flow, hardware, software, and intelligence. Now, I'm going to skip over the obligatory sales pitch and just really get down to my perspective on open robotics, and really just show off where I'm coming from. And I'll get through it quick, so hopefully we can get to the questions and get to the panel. But generally, and that is an animation error. But first, just let's talk about Ross a little bit, and hopefully I'll save Kat a little bit of time. But just to lay the groundwork, Ross itself, as many people know, the version 1.0 was hit in early 2010, and the main release to everyone was the Box Turtle release in 2010. As we go through, there's been a number of other important releases. I've highlighted here the LTS releases, or actually with Groovy, Ross G was where we started officially saying, starting to put support plans in place for Ross, or moreover, that we started to say when it would not be supported. So between G, I, K, M, and N, these are a variety of LTS releases, Ross N being the last Ross 1 release. But more excitingly, in 2017, the first release of Ross 2 became available. But more importantly, arguably, than these piles of code that we call Ross is the community. So right at the beginning, in 2010, and Fergs actually, who's in the audience, and probably a few other people have a lot more direct experience in this than I do. But in 2010, Ross was just the PR2s. And 2011, we had Ross Answers to start actually building a more general community, as well as the Turtlebot, which really took the world by storm, along with by building on the Microsoft Connect to really put autonomous robotics in the hands of people who couldn't afford the PR2, which frankly is just about everybody. And then when 2012 came along, we really started to see Ross become definitely a community of its own, with the formation of the Open Source Robotics Foundation and the first Roscon. Then through 2013 and 2015, 2013, 2014, 2015, we saw the transition of Ross officially away from Willow Garage, and just as an exciting addendum, the first Ross software running in space. And then over the last 5 years, 2016, we saw the Open Source Robotics Corporation start to emerge, which has been very, very important, more important than most people know, to make sure that we can continue to build and support this community and work with corporations, as opposed to Ross being forked in umpteen different ways and shuttered off from the community. And in 2018, we saw a few different, what I would call salient events. First, Roscon Jp, which is the first national Roscon, the first Roscon that was run outside, out of the aegis of the OSRF. So run specifically in Japan, organized by Japanese speakers, and almost entirely in Japanese, which is a testament to how global of a force Ross has become. As well, just to call it out, the Ross and Microsoft officially supporting Ross. And for those of you who haven't been around for this entire time frame, you would know that Microsoft used to have a major investment of their own in the robotics space called the Microsoft Robotics Developer Studio, and shifting to supporting a fundamentally Linux-based architecture, plus changing from their own direction in robotics, is quite the vote of confidence in ROS, and certainly, despite what you may or may not think of Windows, certainly unlocks a massive opportunity to reach a whole new set of developers. And then finally, in 2020, we have Rosworld. Originally, this wasn't going to be as much of a big deal. It was going to be yet another Roscon, but unfortunately, because of the situations we're all faced with, this is the first Roscon to go fully online, which we're very excited about, despite the last minute nature. But I wanted to just, now that I've laid a little bit of the groundwork here, just to talk a little bit about the perspective that we have on ROS. And from when we started, we actually were the first for-profit company to support ROS. We released our first packages quickly after ROS-B. I believe the first packages were officially released on Sea Turtle, ROS-C, but developed on ROS-B. And that was for our Husky robot. And as well, we were one of the, I think they were one of 2 or one of 3 companies to begin manufacturing TurtleBots. So I still remember shipping 100 TurtleBots to Willow Garage because Melanie and Tully were very tired of putting them together by hand. So we're proud to have had that initial, to take that step to make sure that these educational robots were prevalent. And then as the community continued to revolve, we were also very happy to have supported that in lockstep. As Andra mentioned, I'm on the board, and I have been on the board since 2012 when the OSRF was founded. As well, we were some of the founding sponsors for Roscon, and I've continued to organize it all the way, not basically every Roscon since then, and it's been a lot of fun. As the years have gone on, we've taken on more and more support, as similar to many other members of the community, to make sure that this truly is a community initiative as opposed to people just throwing endless amounts of patches at Dirk and William. So for example, in 2014, because of all the work we've done with ROS drivers across the board, we started to take on a greater responsibility of the ROS drivers repository. And also, as Willow Garage shut down, we took over the global support contracts for all the PR2s in the world, and that lasted for about 3 years. In 2015, of course, we launched Auto Motors, which is it's the lion's share of what we work on right now at the overall company, and it is a fully ROS-based robot, as well taking over a greater maintainership responsibility of ROS Control. As the years go on, because we just love taking on the things that are less exciting, we took over, we were, I believe, one of the first community maintainers of Roscom, and we're still a major maintainer of that. And then, because it turns out, unsurprisingly, that you can only push ROS1 so far when it comes to coordinating fleets of vehicles, we began working on ROS2, and we were the first, not the first, but one of the first corporations to really begin pulling it in. And then in 2019, we actually started shipping ROS2 products, or ROS2 as part of our products, into the field. So there are way too many Toyota cars right out there now, which are built in assistance by ROS2 powered robots, or with the assistance of ROS2 powered robots, which is very exciting for us. They were actually the first customer to get that particular upgrade. And then in 2020, just continued to, in the spirit of partnership with both the open source and the for-profit communities, highlighting a few things that some people may have seen, a greater partnership between us and Microsoft, as well as the recent release and maintainership of the Boston Dynamics Spot ROS drivers, which incidentally, my cat does not like that robot at all. So this is just the perspective that we have on the community as a whole. And what I can say is that it is it's an immensely positive and impactful community from the 10+ years of experience I have working with it. And we spend a lot of time, myself, the OSRF in general, others, looking at how we can improve based on working with other communities. And I think we have actually found a very good balance in terms of welcoming of community input in all shapes and sizes, as well as trying to recognize the importance of, well, frankly, funding in various forms, that we don't want the robotics equivalent of the heartbleed bug, for instance. So I'll just leave it at that and give some time to the other panelists and look forward to your questions.
Thank you very much, Ryan. I was so taken in by how much has happened in what is just over
10 short years.
Yes, that's so much. And I'm glad you talked a bit about Rosworld, because I didn't mention that, but I kind of hope that either you or Katherine would. And our next speaker, Katherine Scott, is the developer advocate at Open Robotics, the stewards of ROS, the robot operating system, as you've just heard about. And Katherine also sits on the board of OSHWA, the Open Source Hardware Association. In addition, Katherine was also the founder and lead software developer at Tempo Automation. Tempo's building the electronics factory of the future in San Francisco. And prior to Tempo Automation, Katherine was a co-founder at Sight Machine, and the list goes on. So over to you, Katherine.
I guess I should screen share. I'm going to jump around a little bit and show you guys a couple different things here. Let's see. Yes, desktop. All right. Well, that looks good. So one of the issues I think with ROS is, you know, I have a long talk about sort of the history of ROS and where it came from and how we got here, but I think Ryan's done a pretty good job of doing that for us. And I think if you had to summarize it really quickly, it's that there's this initial 5 to 7 year period where, you know, figuring everything out, sorting things out, building the initial development, proving it works, sort of as when you're developing a product, right? What the military says is they kind of move through technical readiness levels. And I think this sort of this journey of ROS moving up these technical readiness levels to the point where I think we're sort of getting deep into the sort of usefulness of ROS in particular for applications. And given that history, given that we had to move through all these different levels, if somebody sort of looked at ROS 2, 3, 4, 5, 10 years ago, and sort of made their decisions based on what they saw 10 years ago, the sort of situation right now is that I have to go and sort of re-explain it to people and sort of say, well, that was 5 years ago, 3 years ago, 8 years ago. And so I've taken lately to most of my talks talking about just sort of the social proof that people are using ROS. It's not, the people will say, oh, it's just this academic thing or just this open source thing. And the fact of the matter is it's completely not. The slide I have sitting up right here, you guys can see this, right? So this is just the ROS 2 technical steering community. And I think I'm actually missing a few organizations in here, but this gives you an idea of the people that are making actual investments in terms of time and money into building ROS and making ROS what it is today. And I think, the people on that list, gives you a good idea of who's supporting it. But even, off that list, I have my own personal list of everyone who sort of contacts us and says, oh, I have this ROS problem or I'm working on this. That list exceeds well over 300 companies, all the way from like Fortune 50 companies to 1 and 2 person startups. So, and it's all across the globe in all sorts of different vertical markets. Is really quite a few different orgs. I also just sort of use metrics to sort of describe how big we are. And so caveat, this is actually last year's numbers, but this is summarized. Like I said, 300 companies, 250 million dev downloads in 2019, 35,000 Q&A forum users, 5,000 forum users, and I think the updated numbers here are close to 3,000 repos, and just shy of 8,000, maybe 8,500 research citations for the original ROS paper. So that gives you a pretty good sense of how big things are. If I can switch over here, this is the newest metric report. Maybe. I can't move this. Well, we'll press ahead. So the short of it is that we recalculate these numbers. We're looking at probably for 2020 exceeding 500,000 Debian packages for ROS downloaded just off our build farm. That's our sort of canonical build farm. That's not people's internal source distribution. That doesn't include Docker containers. That is just, I have a new machine. I want to install a ROS package on it. And I think that sort of gives you at least an idea of how big things actually are. Now, let me see. Why can't I? There we go. So that gives you an idea of the size and scope of the ROS community, and I think it's growing quite rapidly. And I think what we sort of offer people is this ability to interop fairly with different vendors and different providers at all different levels and different applications within robotics. And that's, I think, becoming more and more relevant. And when I sort of talk about this in terms of history, the early history of robotics, right, is that it was very capital intensive, very like focused on manufacturing generally. And people would have system integrators come in, these groups, and they'd build one specific thing that they're going to, have these robots do the exact same task for 20 years. And it sort of behooved them to keep all of that stuff proprietary. And as we've seen things sort of open up, as people have to become more and more flexible, manufacturing has to become more flexible. The robots, if you're going to put robots in hospitals or warehouses, the robots themselves have to become more flexible, which in turn leads the vendors and the people using the robots to also have to, collaborate more and build bigger things. And sort of this open source environment is where people find all of this collaboration happening. The anecdote that I have for all of this, and this is sort of the sign that I feel like things have really changed. When I started my career, I used to do software for basically system integrators in Detroit, and they'd have nothing to do with anything open source. It was just persona non grata. It's just a waste of time. And recently, like my mentor, who this is almost 20 years ago, had me working with him, would never touch open source, has just come to me and said, hey, we're really interested. We see all these people working with ROS and Universal of ARMS, and the fact that everything sort of is starting to work on Windows. We're really, really interested. How do we sort of hook into this community? So I feel all these people that, took a look 5 or 10 years ago are sort of changing their mind and coming back around to ROS. And I think that's really, really interesting and exciting for us. Let's see if I can get this tab to open up. And like I said, that was not what I was intending to click, but things are moving out into space. We actually just got this rover from the ESA today, so you should go check this out. But, I think on top of just businesses grabbing all of this stuff, it's also fundamentally governmental orgs are coming in now and starting to realize that, hey, we are the neutral platform for building these bigger, broader robotics initiatives, whether they be in space or Department of Transportation or NIST is very, very interested in ROS for its ability to sort of help in standardization of manufacturing tasks. So I think part of that driving factor is now that governments have sort of looked into open robotics and to open source in general, it's sort of bleeding over to the community that supports the government, which is a huge, huge component. If I can get my Rosworld. Sorry, I can't see what I'm doing. There's a big bar across the top and then it won't let me click over. So as Andra said, we actually do have Rosworld coming up. So this is, I think, our 11th big conference. Because of COVID, we've made this all online. It's completely free. And this is sort of the spot if you want to come and meet other people working on ROS applications, see what's new and interesting out in the ROS community. It's November 12th. It's free to register. It should be really, really good. I sort of curated most of the program, and I've been seeing all of these sort of contributions come in, and it's looking like a very, very fantastic program. We've overshot sort of our plan for attendees already. So people are very, very interested.
And you're giving the opening talk.
I am giving the opening talk. It'll be a little bit more well-rounded than this. And then finally, all of this open source development, it's not static. And so I think the last bit to keep in mind here is, especially right now, especially as we're really trying to help people move from ROS 1 to ROS 2, we need people to come and tell us how we should shape that future. Initially, I think ROS was successful because we built a lot of infrastructure for community support, like the ROS Wiki and Answers and ROS.org. There's all of these tools that people use to sort of learn ROS. A lot of those tools are starting to show their age. They look very, 2005, 2007, and we need to sort of push them along and, bring them into the 21st century. And so we're always soliciting people for input on how we should do that. So right now we're really, really interested in sort of, hey, you're building a component or a piece of software that's going to go into ROS 2. How do you want to basically fold that documentation into ROS 2? And so we're sort of soliciting people for comments on that. We're also looking for people's feedback right now in terms of the ROS middleware, which is the layer that does basically all the communication inside of ROS. And we're looking to get people's input on how that experience has been going and sort of what vendor they're having success with and what that process looks like. So that's the short of it. I think the quickest way to sort of plug into ROS is to go to ROS Discourse and start poking around and seeing what interests you. I don't want to take up too much time either.
Well, thank you, Katherine. There's a lot of information there. I'm always staggered by how much information you can pack into such a short time as well. Now, one of the things that I saw working with so many startups in Silicon Valley Robotics in the last 10 years was the incredible increase in the number of startups that were using ROS. It was quite remarkable. Although what I would hear frequently was that the startup would say, well, we're going to be using ROS for all of our prototyping and developing. It's really how we're getting going rapidly, but we won't use it for our production. And so I've had this association that open source is really amazing for prototyping, for hobby, for community, and that it is not the foundation for a commercial business. And I think we've got some speakers who are going to be proving me wrong in a second. We're about to hear from Kent Gilson, the co-founder at Haddington Dynamics, and Jason Hampton-Taylor, who's the International Director of Sales and Marketing, which is a very big title for a very small company. But I believe that you guys are living up to it at the moment, aside from the fact that, Jason, you're in Australia right now. So there's a lot of big news for Haddington Dynamics. And Haddington Dynamics make Dexter, a new 3D printed FPGA industrial robot with open source technology at the core. And you've made some pretty interesting decisions around the way that you're commercializing your robot company. And I'll leave it at that. Over to you, Jason and Kent.
Cool.
Great.
Thank you.
Yeah. Hello, everybody. We're going to kind of tag team on this. Jason's got all the marketing material, so I'll talk and he can interject and then add stuff to it. So, when we were asked to do this, really talk about the economics of open source. It's kind of half of our business model, right? There's another reason for doing open source, which for robotics is has to do with more the socio impact of making sure that everyone has the access to the means of production. But the economic decision making was very precise and deliberate to facilitate both our business model and also the fact that we had very little money to pull off something that we believed in the very beginning would not be financeable through traditional venture funding. So we call this the $600,000 business plan, which is how much we had to start. And the basic idea is open source and patent. There's a conflict of there's two different ways to go about this. We could actually patent, create a whole bunch of patents and then and then try to, finance and build a company normally around that, or we could leverage the unique characteristics of open source to mitigate the amount of money that we had to, to pour into this in order to get to a minimum viable product. So and I'll try to describe this in juxtaposition to patenting. So there's a couple of issues with patenting, and one of them is you need about $1 million to start patenting, and that's because if you're going to patent, you need to both defend it, produce it, and also hire and collect human resources for at least a 2-year period for the time it takes to actually get something patented. And that kind of limits your flexibility in fundraising. So I guess a good example would be, the concept of rock and roll actually was brought about by the access to 4-track recorders. Prior to the 4-track recorder, it cost $1 million to put together a studio, and so the number of people that could actually, and so you had to amortize your distribution across the broadest market that you could. So you couldn't have these what were considered niche markets going in and consuming $1 million studio resources in order to create these new media formats. So that's part of the economics of open source. So with open source, you can actually get people to help you build build out your system. But and we did a Kickstarter early on, and we actually open sourced the initial robots prior to doing the Kickstarter. And so one of the other features of patenting and open source is that if you have a very simple adjustment, modification to a hook to hang a shower curtain, so something that's very easy to reproduce, then that might be a reason for a patent. But with something like a robot, it's such a complex system, and we've got we did the chips, we designed the chips, we designed the boards, we completely redid the architecture of the robot. We used 3D printers as additive manufacturing to be able to iterate hundreds and thousands of times on the mechanical systems, and so we really didn't know what how many patents or how many how much money it was going to take to do this. And the idea of having an open source, if you patent something, you have to tell someone exactly how you do it, and so that someone skilled in the art can reproduce your idea. But with open source, you don't actually have to tell anybody how you did it. You just have to publish the source, and with tens of thousands of lines of code and chip design and hundreds of mechanical parts, it's very difficult to reproduce what you're to deconstruct from just source all of the capabilities of the system. So we knew that we didn't have a problem open sourcing and marshaling the community and not having to patent our technology, because we were going to be changing it. Well, we can change it on a daily basis. In fact, we go through rapid development of both the hardware and the software and the chips on a 2 or 3 times a day. So there was really no fear of anyone catching up with us. And so we combine that idea of a very rapid iteration and open sourcing to collect a community to help us develop this quickly, along with this idea that we were going to out innovate anyone else, and we wouldn't need to patent. So it's turned out that also the business model has to change a little bit. And so one of the things that we've been doing is we've opened up not just the robot, but we're also now selling microfactories. We're actually letting the community build the robots, and actually so our product is more of an education product. We actually teach people how to build the robots. We have a product called a Makeation, where people come into Vegas and sit down with this, and we'll actually build a robot with them, and they pay us for that. So with the idea of open source, also our primary market is not so much the traditional automation marketplace that other robots go to, but it's the design win. In other words, there are lots of people out there who want to put automation into their product. In other words, they come and they build a robot, and they've got a product like a gluing operation, a company that builds glue, and they want to produces glue. They want to build an automatic glue dispenser, but instead of buying a robot, they want to buy our robot. It becomes a component in their own in a line item that they can sell, and they can brand it themselves. So they come to us and they learn how to build the robot. So they understand that it's a very simple process to put together a robot, or at least a reproducible process. And then they'll buy a micro factory from us, so they can actually start producing their own robots. So open source brings with it both the opportunity to incrementally evolve your product, marshal in a larger community. You don't have the cost of patenting, and you also don't have the risk of someone patenting out from underneath you, because with the open source license, any derivative product becomes automatically open source. So it has the effect of actually keeping out the traditional OEMs, because they don't want to get involved in it. So that's the final the real economic value is building these micro factories and let everyone sharing the margins with everyone. And then the way we capture the money is just by being thought leaders and kind of an R&D team for these micro factories. And Jason can talk a little bit more about the micro factories. But so open source is gives you a lot of advantages. You have to think differently about your business model and how you interact with the community, but you have to think about it as an education play, as opposed to cranking out a million robots from a factory. Jason, you want to add something to that?
Yeah, no, thanks. Do the tag team at this point, I think, but yeah, Kent and I have now been working together for about a year and a half now, really. And as I sort of had been previously working in Australia, building an idea of 3D print farms. And so once Kent and I met, it was obviously great for me to bring my previous experience to add to exactly what he was doing. They were already ahead of the curveball in terms of going away from a traditional sort of factory to build this product. And that was the key to the open source. So rather than setting up what we sort of sometimes call, and this I'm showing my presentation here, the sort of the monolithic factory. This would be our normal route to market. We design a robot, get it built, maybe use the 3D printers, and we use high strength 3D printers to just get that basic prototype together. Then commit to $7 million worth of tooling and a big factory to try and build these things, and then be exposed to maybe having to, sell 10,000 robots a year just to, break even. The other option, is to do it in a very different way, and this is the way that we've chosen to do it. From a sales perspective as well, I have to say, not being tied in, and I've been involved with some startups with patents, and NDAs have to fly everywhere before anyone can talk about anything, and it holds up that whole sort of liquid motion you want when you're communicating ideas. With this, is very, very open. We can talk about virtually everything. But basically the idea is that we have, instead of one big factory, multiple factories, which, as Kent said, could be easily adaptable. Could be, certainly go into an embedded situation with an existing factory to add value to their offering, become a sub-assembly, or certainly be a microfactory in a regional area somewhere where maybe we want to start, or with maybe some support, try to increase high-skilled jobs in an area, making robots. I'm happy to say now, with the first microfactory we did set up was here in Australia, in Toowoomba, a company called Decisive, and we are now this month doing our first exports from Australia to America for robots. So I think the first order of 4, and then we've got another order of 8. And it looks like, because they were the only microfactory we were able to complete before COVID happened, the Aussies are going to get a lot of business. So we're looking to do that. But yeah, so in terms of, you know, from, if I take it back to the core principle, we were talking about open source hardware. I mentioned before, from a sales perspective, it's very great not to have to be tied down to IPs, but it's also really not, it's great to be able to reiterate quickly without being tied up with additional sort of paperwork. As you can imagine, iterating a new design in a traditional place would involve 5 meetings as opposed to probably the 1 meeting that we have to achieve the same results. And there's no compliance, there's no, all sorts of different elements go into it. We're able to reiterate designs really quickly. We're also able to have certain microfactories devoted to a certain market sector. Right now we have people looking at microfactories devoted in food production, in medical supplies, in engineering. We're able to address a whole bunch of different vertical markets simultaneously. Now, just to, I'll tie up my little bit here, but, you know, just to tie it back to the previous speakers, you know, we also have a burgeoning ROS community getting involved as well. We have a Discord channel, and we're asking for people who work with ROS to help with us as well. So we'd love to be able to, you know, jump on board with Katherine and Ryan and be part of, you know, just the cohort of open source people. And I see in the comments that Ryan had some questions about what we're doing as well, and opinions, not so much questions. That's even more interesting. So you know, we're open in many or more ways than just the open source hardware. So thank you for your time from us, and I'm sure we'll be hearing some more questions.
Thanks so much, Ken and Jason. And you've really, you know, I'm continuing to struggle with the idea that you proposed in general. It seemed to be turning everything on its head from what I'm expecting. And that's true. And for very good reasons, though. I do think that my curiosity is why I really wanted tonight to not just be about open source robotics, but about the economics of open source robotics. Why are we doing it? What makes it worth it? Where is the values? And along the way, we hope that there's great social value as well. Now, there's some fantastic questions in the chat, but I think it would be great if we let Camilo speak, and then we'll go in for the discussions. Ken had to leave, but he did want to say how much he'd been enjoying the discussion, and he's a huge fan of open robotics and ROS. And but I think we're not going to have any problems with discussions. Camilo Buscaron is the lead at Amazon Web Services for robotics, and I'll hand it over to you, Cam.
Yeah, thank you so much, Andrew. Thank you, Ken and Jason. You know, before I start, I definitely want to thank Andra for the relentless work to putting us together, bringing us together. I think you're an unsung hero that, you know, doesn't get all the credit for how hard you work to keep the community going and keep the conversations and make this avenue for the people, right? I think, you know, we come for the audience, but you help us come together. So thank you. Yeah, I think you know, today I'll take a little bit of a different approach on the conversation. I think Ryan and Kat and Ken have provided a great insight into where we are today and how we came to be here today. I want to give you my perspective on what I believe is going to be a key driver for the future and what is going to be a key enabler to even, you know, today there's maybe 10,000 robotics developers, and the broader software engineer group is maybe in the millions, 20 millions or so. So how do we increase the deployment of robots, the number of developers, etc. And just as much as ROS has made it possible for the acceleration of robot development, you know, 15, 20 years ago, everyone had to develop their own software framework. You know, I was in a research lab at the time. We had our own framework, and every time there was a new generation, there would be a new group who had to develop a framework. So sort of how you know, ROS has come to being able to do that. And now, you know, then eventually the emergence of partners like Clearpath, which now make robots. Everyone doesn't have to, in Haddington Dynamics, you don't have to make the robots from scratch. You can buy a robot, use a robot. But I think a lot of developers still use robots too much. I think there's a way to accelerate that, and I'm going to tell you about that. So I'm not going to talk much about ROS, but I'll tell you about sort of the traditional robot application development and what that has traditionally been like, and how is that emerging now with new capabilities that are available in the cloud. And then I'll tell you a bit about some of the services that we have built on top of ROS and Gazebo, which lead to this development. So, usually a company starts building a robot, you typically start with what is the customer need that I'm trying to solve, right? After you sort of figure out what is the customer need, you sort of hone in the specific value or product that you're making. In this case, I'm going to run you through a quick example, which is we're going to make a spaceship application, right? So if you wanted to make a spaceship application for a robot, first, you had to design a prototype of the spaceship. You had to manufacture the components of the spaceship. Later, you had to develop the firmware for all the robots, for all the motor controllers, motor drivers, and main boards. After you have the firmware, now you have to develop drivers for that robot. After you have the drivers, you have to integrate, start testing, and you can sort of start developing your application, the spaceship application that we're building, right? So this process traditionally has taken a long time. Many labs, and I hope Ken would have stayed here in the call, because a lot of a robotics lab would have to build their own robots, build their own frameworks, and because that's not the case today, things have been able to accelerate. So this process takes a long time, right? Going from designing a prototype to being able to build an application. So how can we accelerate that, right? Well, now we have ROS, which is just a big bag of building block software. And if you have a simulation environment, which you can couple it with, in a few hours, you can have a sample application, a prototype.
Excuse me, Cam, are you screen sharing?
Yeah, it's not sharing.
It's not showing. I'm sorry about that.
Oh, sorry. So I there you go. Well, I was showing this.
It's showing now.
Nah, it's showing now. Okay. So I was running through this, and now my slides. There you go. Let's see. So I'll quickly. Well, so this is what I was describing to you, right? You have to design a prototype, develop an application, etc. But now, if you have a big bag of building block software like ROS in a simulation environment, within a few hours, you can prototype an application, right? So yes, that application might not be the end product because it lacks some finished details. It might not be exactly what you're ultimately going to deploy, but it gives you the ability to easily modify and extend your development. And then once you figure out what is your real key value add and your intellectual property, you can build a specific component around the open source software, and you can start adding value to your customers or get your product to market, right? So what makes this possible today? Obviously ROS, which is something we discussed earlier, enables the building blocks to build a lot of the software. A lot of the tooling that's available in ROS today makes the software development for robots possible. Gazebo as a simulator, Arvis, RQ. So like Ryan said, obviously these things are not possible unless community is contributing and building the software and contributing to the roadmap of development. At AWS, we not only believe this is the case, but we actually roll up our sleeves and contribute directly to the ROS 2 roadmap on behalf of our customers. We decided to not build our own middleware and just work with the community to extend and make it more robust, make it more reliable, secure, and provide that to everyone, right? Our customers included. And we do things like cross-compilation tooling, the latest features for ROS bags in ROS 2. We've added a lot of quality service features. So we're not the only ones doing that, right? We're part of a broader community, as Kat and Ryan mentioned. There's a number of companies contributing to it, making it better, and that's what it takes. It takes a village to get to that point of adoptance and the level of adoption and deployment. So just the key takeaways, right? Open source is a force multiplier that helps grow hardware and software ecosystems. You know, when I work with our customers, I always help them to figure out their open source strategy as part of that, right? Always they can add value, higher order value in the chain, while contributing and having a win-win with the communities. So part of that, we have built a service that helps customers simulate, test, and deploy applications in the cloud. We have a Gazebo managed infrastructure that helps our customers develop, test, and do validation and verification of their applications. Something that we've heard often from customers who getting started in simulation was that they had a hard time creating worlds, simulation worlds. And by the way, this hospital world that we have here is part of our collection of open source worlds that we have made available on GitHub. So most of our customers run into this issue that they have a hard time. The bottleneck for them to get started in simulation is being able to create worlds. So we listened to them, and what we did is we went ahead and we built a service that helps customers generate worlds and randomize the items in that world. We've started with a home domain, so you can build and accelerate the way you make worlds by randomizing the layout, and you can build tens and hundreds of worlds. And I'm going to show you a quick video and demo of this, and hopefully this is, although you might have missed some of my first slides, this might be the highlight of the presentation. So let's take a look. Let me know if you're here.
Introducing AWS Robomaker WorldForge, a new capability that makes robotic simulation easier. AWS WorldForge makes it faster, simpler, and less expensive to create a multitude of 3D virtual worlds to simulate your robots in. Robotic companies are building increasingly sophisticated robots with autonomous capabilities and artificial intelligence. To develop these capabilities, developer teams need simulation to test and train their robots. Scaling simulation unlocks the ability to make regression testing more robust, reinforcement learning faster, and synthetic data generation more affordable. Until today, it was difficult for robotics teams to do simulation because building even just one 3D world was costly, time-consuming, and required specialized skills in 3D modeling and knowledge of simulation engines. Given the investment needed to create a single simulation world, it was almost impossible to build enough worlds to effectively scale simulation. With WorldForge, robotics developers can easily increase the scale, speed, and variance of simulation, improving the quality of production code and accelerating time to market. In this demo, we'll show you how to create dozens of randomized, realistic simulation worlds automatically. Before you generate the worlds, you define your environment template, which will be used to generate randomized simulation worlds. WorldForge makes it easy to customize the assets in your worlds and set variation parameters of your simulation worlds. Starting from a pre-made template, you define the number and type of rooms you want and specify the room's area and ratios. You can customize the room type, layout, and even say which rooms will be next to each other. Finally, in the room itself, you can choose custom floor materials, wall materials, and furniture types. After the template is defined, QA engineers and robotic developers can easily generate multiple randomized simulation worlds for different application testing and reinforcement learning scenarios. Now, I'll show you how easy it is to generate worlds. First, define the number of variations needed for the floor plan.
So as you see, those are sort of higher order tools that you can build on top of frameworks like ROS and Gazebo. So I think that those would be key enablers for the community to develop algorithms faster, test them, validate them. I spent a few years building robots, and where I really learned the value of simulation was actually when I moved to automotive. I got to learn how automotive companies actually maintain development programs on time and on budget, and they get to a level of manufacturing by having the stages of validation and verification. So wholeheartedly believe that, you know, for the next stage of robotics development and deployment at mass scale, simulation is going to be a key enabler.
Thank you very much, Camilo. That, I definitely think that was a bit of a showstopper. The simulated worlds, I can just see so much benefit from having access to that, and that is a very difficult thing. So I was writing down what to do and who to tell about that. But I really enjoyed you sharing some light on how simulation has made the economics work for automobile companies. And I see we've got a few great questions that are looking at a number of the topics we've talked about tonight. I'm going to start with the most recent question and work backwards to I think perhaps the biggest question at the end. So the first question is from Zach Bright, for the team, and he's just adding huge props to the Amazon robotics team, AWS robotics team. And well, if I'm really starting with the most recent question, then his first question is to you, Cam. Can we look forward to WorldForge randomizing some of the physics of the worlds slightly for, say, more robust policies that throw out policies that might be leveraging quirks in physics engines? Ooh, interesting.
Yeah, so obviously simulation fidelity is one of the key needed things to being able to have a reliable simulation. You know, one of the things I've always asked anyone who would, you know, come interview with us or tell us something about simulation is, so how do you know your simulation is valid against reality, right? So physics is one of the main characteristics where you need the most fidelity depending on the use case, right? So yes, you know, we just launched the product about 2 months ago, but we're continuing iterating on features that our customers are asking for, and being able to have reliable physics is one of the priorities in our backlog.
Okay. Well, what about having variable physics? Would that be a possibility so that you can really push the boundaries? Right.
So with Gazebo today, you can actually change the physics engine that you're using, Gazebo supports a number of physics engines today. The default is ODE, but those capabilities are already there on Gazebo, which we provide them.
Okay, and I think there's a follow-on question, but around the other engines outside of Gazebo, we can put answers into the chat, because what I do want to do is get to the other questions, including Yash's question around security. But let's go next to the question for Haddington Dynamics about how do you model defensibility? Zach adds, the nimble aspect of microfactories is quite clear, and the license means they must attribute, but how does the business grow and sustain when you're big? What stops copycats undercutting your process and your prices? Sorry.
That's actually really, yeah, that's a really good question, and it's a couple of phases, and it's really, you know, once you hear it, it's fairly obvious. It's kind of traditional scale, you know, on the back end, but on the front end, we use 3D printers a lot of you know, additive manufacturing and very quick iteration steps to make this happen. So really the value of the ecosystem is that you're continually connected to us and the ecosystem, and we're making, you know, modifications to the product so quickly that if someone, you know, tried to do this outside of the ecosystem, they would very quickly, you know, diverge from where we're evolving the system to be. And and also we are using the robot to actually build the robot too. So I mean, our robot is more precise than the parts that it's made of. And so we're very rapidly driving the cost of manufacturing these to a commodity, you know, pricing model. And so in the very beginning, it's really this rapid evolution of capability. It's the same kind of economic model that that Prusa enjoys, right? They are using an open source printer, but they're using their printer to build it, and they just happen to be, evolving their printer faster than the community can develop it. And so they continue to stay on top of, they actually have a better printer than the other, open source printers that are out there. So at first it's just access to the technology, and also we sell a microfactory for less cost than it would take for you to actually try to reproduce it without our help. So with our help, you get tied into the ecosystem, and you learn the advantage of actually having the scale of the ecosystem drive your profitability. So yeah, there may be so you have to incorporate the growth of the ecosystem as part of the economics and the value of it. And by the time we get to a few hundred microfactories, there will be so much kind of innovation and production energy in there that it won't be cost effective to compete with it. So it's the kind of the winner take all positive feedback, friction free adoption that we're trying to create with this, and that will that tends to push off the other well-funded commercial OEM types of enterprises that want to commit to this. And eventually, the robots are going to be building themselves. So then it really is just access to collective buying and really the economics of large systems that then drive the value in the collective.
I mean, the other thing on top of that, I'll just quickly add to that, is we're looking at the sales side of the thing that is not normally figured out with a lot of startups. I don't know why, but on the other side of that, we're going to shy away from going into these price sort of arguments. Undercut pricing is mentioned in Zach's question. We're going to be looking at robots as a service as our premier offer. We're going to be trying to keep people on less than a 36-month life cycle. As robots as a service is deployed, it's more of like a leasing arrangement. So it becomes an operating expense rather than a CapEx. So once you go into that realm and we can tie the service agreements into it, that becomes a lot stickier as an agreement. For somebody just to try and undercut you is going to be a lot harder. On top of that, we're looking at non-trivial integrations. We're looking at people we're solving one of their dull, dirty, or dangerous jobs, whatever we're doing. That again is quite a sticky application. So we see a lot of customer retention with a good churn rate as well. So there's a good economic model at the back of it.
It's high tech, high touch, right? The microfactories, they get to serve the people that they know in their community, and that has much higher, stickiness than something coming in from China where they've got no visibility into it, and as Jason is talking, it really is a very technical, highly integrated system, and you need to have the people that understand you and your business, they're helping you.
Thank you. That definitely makes a very, very strong answer. It just has me wondering why there are so few people attempting what you're attempting, but it's really,
that's what's beautiful about it.
I'm going to say, really, there's a timing in your favor where you're delivering a new technology at the right time for the adoption in this particular fashion. Now, I don't want to leave Yash's question unanswered, and I think to everybody here, how do we address the question about security with open source?
Look at Linux. I mean, what's the most secure systems out there? I mean, that's open source. I mean, having visibility into your system is not a detriment to your security. Having the right security architecture is really the solution to it. And with our robot, we've got the ability to have a physically unclonable function as your root security mechanism, and then having a digital key store connected to your hardware, not plugged into your operating system at all, is the root security mechanism that you need that you can then build on top of that. So visibility into a system actually opens up the opportunity for other contributors to point out security flaws in those other layers. But it really doesn't have anything to do with the security architecture of the hardware.
Thank you, and I think that is a really good point. It's what better way to keep something secure than to have as many people in the community as possible trying to break it.
Yep.
And then maintaining it.
Why would you assume that a closed source solution has better security to begin with? Like,
Exactly.
That's a really good question.
Yeah.
I mean, I've seen, I mean, the Internet of Things is a pretty good example of how that's not the case. I mean, you know, security is the effort that you're going to put into something, and the more people touching something, the more likely it's going to get fixed.
Yeah, and in fact, we don't have a valid mathematical model of security. I mean, right now, you know, it's like in the old days of alchemy. You know, we don't have the periodic table yet where we can, you know, definitively say these steps will give you security. So right now, security is whack-a-mole. If something pops up, you gotta knock it down. The more people you have, playing whack-a-mole, the better your security is going to be.
Okay, thank you. And now the final question. It was the big one right from the start. And Zach, thank you for such great questions too. Let me just, we've all read it. What do the panelists imagine could be done with something similar to ROS in the more broad hardware space? What would it have to look like to really work?
Well, we've got, we use 3D printing as kind of our primary, fabrication technique. And we see that as an opportunity to, because in order for open source to work, you need to be able to distribute it without, barriers. And so with 3D printers, the proliferation of 3D printers, the idea of just distributing the actual, design files or print files, and then, and then the software to control them is kind of the mechanism to make that happen. Now, the actual architecture of the individual sensors and the actuators, well, and with additive manufacturing, 3D printing, the concept of a standard actuator, kind of gets subordinated to the idea that you can have any permutation of geometry that you want in it. And so, it's really about including the transmissions and including your sensor systems. So,
okay, so your answer is that it's bound to the method of production. Really, yeah. To cut to that. Ryan, I think you had some opinions.
Yeah, I certainly have some opinions actually. I think first and foremost, I feel that anyone who's really interested in open source robotics, the first place they need to start is really familiarizing themselves with the scale that modern manufacturing operates at. And I'll say this as a fan of 3D printing and as someone who's actually supervisor at one point in my career, was at one point the VP of engineering for Desktop Metal. I'm a fan of 3D printing, but there are massive opportunities of scale in modern manufacturing. And if you want to make robotics really easy to use, you want every single vehicle out there to have an API. You want lawnmowers, you want cars, you want ATVs, you want drones, you want everything out there to have an API. That's the cheapest way to proliferate robotics. It's not just random modules and 3D printers. I'm sorry. Like, modules and 3D printers are great for building on top of this stuff. But, speaking of someone who has shipped literally thousands of robots to various parts of the world, the way you get the cost down to make it accessible to everyone is to build in quantities of smartphones so that you can hack on them and you can put them in the hands of everybody. And then when someone finds that product market fit, they can go to any one of these companies and say, take this janky stuff I built out of duct tape and 3D printed brackets and circuits, and then expand from there. There's a massive graveyard of companies that have built modular robotics, and it is really great for researchers, and we will partner with them all day. But to expect that a systems integrator will just randomly bash some robot parts together, it's quite plausible. Like, I'm not saying it's technologically infeasible at all. I'm just saying the scale of modern manufacturing with things like injection molding and stamping and rapid PCBA is truly ridiculous. It's truly spectacular, and that's the sort of thing that's going to stand in your way of building a module that's also that you can build, sell 10 million of. I think that's there's a lot of work which can be done here, but really when it comes down to it, there's always going to be that cost standing in your way.
But isn't it that traditional idea that straight away we go into mass production? This is probably what I was alluding to before. You're going straight into minimum order quantities of 1,000. So just to tool up for your plastic injection molding, you're looking at exposing yourself to massive overheads to tool up for the sort of numbers that you're talking with. So then it damn well better work, because to reiterate is real tricky. So what you're also explaining is the traditional dilemma that we have now. Yeah, 3D printers. Maybe you're probably sort of appropriating the way that you're thinking about these things, because I see if a 3D printer is slow, double the speed by 2. Get 1,000 3D printers, and you have a really flexible hive-like way of 3D printing. And if you put robots on top of that, then you have a very scalable factory where it's not stuck on a linear timeline. If one part of your injection molding machine breaks down, the whole line stops. If one of our 3D printers breaks down in an array of 100, that's easy. We just zoom around to the other side. And we're also talking about things like, when we're looking at 3D printers now, we're looking at stuff with carbon fiber, to bring up we've got a flexural strength of, 500 megapascals just from nylon, not alone going into the, titaniums or Inconels, all these new metals that we're also talking about. So I think it's the flexibility of these modern systems allow us to reiterate, change problems, not be stuck with 1,000 parts when that's a duff part, and to avoid all those big economic pitfalls. I would challenge you on that presumption that we need to go to that big, massive production, because that's a major overhead.
At no point am I saying that we need to go. Sorry, go ahead, Kat.
Oh, well, I was going to interject. So the reason I asked for clarification on this is the ROS ecosystem as it stands, right? I can go to SICK, I can go to Velodyne, I can go to Ouster, I can go to Clearpath, I could go to Intel. All of these companies have hardware modules that have ROS interfaces. So I don't understand the fact that there's not, how are we going to get to a ROS hardware ecosystem? It exists. I believe it can be better. I'm consistently working with vendors to make that happen. And I think a little bit of that is just, it's first, the vendors of most of these hardware components are still trapped in about 1997, where I call them and they, I have to go sign an NDA to go see, how their thing works. And their source code is in a zip file that they send to me once every 3 years with updates. So part of that is just working with the hardware vendors to get them to the point where they actually work with modern engineering development. And then, having them come to a realization that they can have a ROS interface on top of what they already do instead of a replacement. I think there's a lot of FUD about ROS where it's like, oh, that's going to replace what we've done. And it's really, no, it's an API into what you've done so it can work with a bunch of other things. And so I think things are changing. I think me pushing on things, and then to be quite frank, we have a lot of inbound now where people are asking, how do I get my thing to run ROS, which I think is great. With ROS 2, I think the most exciting change is the fact that there's micro ROS, and that hopefully, if you're running, you have a sophisticated device or a less sophisticated device that's running basically a microprocessor, you have a way on the RTOS of that device to run a ROS interface. Because the way we've been kind of doing stuff before is acceptable. It's just a lot of work because you have to basically take their API and then go and wrap it and all these things. Now you can actually just have something that talks ROS out of the box. And you can get that I think plug and play is a little overrated, but I think we'll get there pretty quickly where it's just like, oh, here, I can see all the topics. It just works. And I think eventually there will be components like that, especially as you start seeing things like, hey, I have my car. I want my car to drive itself faster. So I want to go swap out, say, the SICK on the front of it. So we need a standard interface for that.
So you're seeing a lot of different things, not necessarily robots per se, the whole kit and caboodle. Mm-hmm. And I thought that that was really where the question was coming from. Do we need to replace ROS for the rest of the hardware world? And I think you're talking about ROS becoming, you know, smaller, more flexible, more adaptable, so that it is relevant for anything.
Well, I fundamentally think, you know, there's a lot of nonsense Internet of Things protocol, right? At the end of the day, and a lot of those are built on a pub sub bus, which is all ROS is fundamentally, right? Like even, you know, Google protobuf is to a certain extent not that dissimilar from what's happening in components of ROS underneath the hood. To me, it's, you know, I have this very broad sense of robot where robot is here's some actuator and here's some sensor and you want to put some goo between the two and make it do something interesting. And I have that broader view of robots versus the very narrow view of like it's only 6-axis arms and AMRs.
Well, and Kat, I think what you said is basically where I'm coming from. And first and foremost, I'm not anti 3D printing. What I'm more saying is that the people who want to talk about modules and 3D printing should be aware of what 3D printing fits in the broader manufacturing ecosystem. And we 3D print stuff for prototypes all the time. We have, like, we recently built a one-off robot that looks like a satellite. And of course, there's a lot of 3D printing stuff. But at the same time, you know, you want to build 1,000 injection, you want to buy 1,000 3D printers. Well, I can buy time on an entire injection molding time for a line for a few months to do that. And I'm just saying, like, there's a lot of new options there, and 3D printing is just another tool in the toolbox. It's not a fancy.
I use my home CNC to make my own injection mold. So where does that put me? Like,
yeah, exactly, right? Like,
I love this because I think what COVID brought to me, what I realized when our space started trying to make PPE was that we needed to be producing in multiples of more than 100. And the majority of the equipment we had was not cut out for that. So we now have die cutters and we're looking into injection molding. And I thought this is a step forward for makers and everywhere. That equipment ought to be accessible. It ought to be equipment that people are able to play around with a little more. If we are ever, and this is the if there, if we are ever going to reduce the need to have really large, really monolithic manufacturing industries.
well, and maybe like to talk about open source hardware in particular, like I would say just off the top of my head, there's 3 reasons why I do not open source every single instance of hardware that we build to the world. The first is that though the engineers usually value the fact that they would still buy it at reasonable price from us, the procurement departments who we sell to do not. And they would take every opportunity to go through the BOM and say, this is your margin, we're going to cut you down on this, and that's just the way it is. And it costs us more money to run the business. And that is an unfortunate reality of what procurement departments are compensated for. So, you know, I'd love to just give all the engineers around the world our parts, but, you know, then the procurement departments would make it impossible for me to stay in business, which is unfortunate. The second is that, as you know, as the ROS community knows, it takes an immense amount of documentation to open source anything. So we are very judicious about what we feel is worth the documentation. And to another point, actually, there's a 6-point internal test, but I won't go through all of it. The other point is, like, what can people actually work with? If I open source the Husky or the Otto or the Ridgeback designs, for example, you need a lot of tools to work with it. You cannot 3D print a Husky short of having like $1 million metal 3D printer there. You need like CNC, you need CNC laser cutters and CNC benders and all sorts of different experience to actually build something from scratch, much less all the PCBA tools. Like, that's just something you need to build something that's larger than a bread box. And it's like the limit, there's like limited value that we could put all of our instructions online for how to work with our open source tools. But in the end, it's going to be way cheaper on a one-off basis to just buy it from us versus to put in the, you know, $10 million of CapEx that our suppliers collectively have to do it. And I mean, we haven't done that. We actually work with our supply chain, and that's great. But I think that's, to Katherine's point, that's open source. That's how we forward robotics. It's making sure that it's like every sensor has an API and integrates well. And every, I use the example of lawnmowers. I'm actually going to buy an electric snowblower later this week because, Canada, or later this year. And I'm really curious to know what kind of motor controller it has. But that's really the cheap way to really get robots everywhere. And we have research partners who, what they do is they literally take our robot and they cut it into pieces and they reassemble it with like bolts and just random pieces of metal. And we support the remains. But that's fast prototyping for them.
Now, I'm led to believe that you just laid down a challenge, apparently.
You can't 3D
Are
print
you
a Husky?
saying you can't 3D print a Husky? Do we have anybody that would like to take Ryan up on this challenge?
What's the payload on a Husky? What's the payload?
You max out at about 100 kilos.
So,
And it's all pretty much hollow inside.
oof. So the
So you're going to have a lot of thin-walled metal printing.
Yeah, well, I mean, obviously, this leads to a larger discussion of traditional manufacturing versus additive manufacturing. It's probably out of scope for all of this, but so we could, we have obviously two very different perspectives on how you fulfill the promise of low-cost open source robotics. I just have one question for you. What's your definition of low cost?
Like what's my definition of low cost?
So just for instance, it's a rhetorical question. If you buy a microfactory and you build robots, you can build a 7-axis, 50-micron repeatable, 3D printed robot that can carry 30 kilograms for $2,500.
Low cost is what the market will bear for the product.
Well, that's an easy out, though. But what's someone at the coalface who sells stuff, there's definitely a market.
Yeah, I mean, $2,500 for that price point is spectacular cost. But the thing is that usually when someone buys for that price point, they also expect it to, to last for 10 years and to have a support and have a support team that answers and all of that.
Earlier on, I mentioned the 36-month life cycle, so we don't want to be selling these things.
Oh, well, RAS is a very, very different discussion, which is
well, not really. So we're talking about the delivery of the item.
Yeah.
Why is that a different argument? It's a pretty pertinent one, I think.
We're going to make that a topic for another evening.
Great idea.
I know we've really overstretched, but the discussion has been fantastic. If you have a very short closing remark, I will go to each of the speakers in turn for it, and I will even give you a prompt. What's the biggest thing happening in robotics at the moment? Ryan, would you like to start?
Sure. I mean, I think the biggest thing happening in robotics right now is people starting to realize the importance of delivering value as opposed to prototypes. I think a lot of new startups and slightly older startups and companies are realizing that this has to be more than a science fair project. And over the next few years, everything from small 10-person shops all the way up to multinationals with billion-dollar self-driving car initiatives are going to have to, there will be a reckoning, so to speak. And that reckoning will come in the face of, or in the form of, does this actually help? And I think, open source robotics can definitely speed us on their way, because no one wants to be messing with drivers while challenging these very fundamentals of their business models.
Thank you, Ryan, for sure. Kat, over to you.
Okay, I'm going to do two, because the hottest thing right now is going to be Rosworld in about a month. Everyone's going to be there. The second one, Ryan's about spot on. The other thing I would suggest is just simplicity, the primacy of simplicity. Because fundamentally, I've seen self-driving cars drive around San Francisco for 5 years, and they haven't really gotten much better. But I also see robots doing simple things and doing them much more often and delivering much more value when they do simple things. And I think we need to crawl, walk, run in some respects.
Great point. Jason and Kent, over to you.
Well, I'll just add one. Jason, you can add one. There is a massive disruption going on right now in low-cost robotics that are getting into small and medium-sized enterprises that don't have the traditional, integrator stack and programming requirements, and that's going to become apparent in a few years.
Thank you. Jason?
And absolutely, and I'm at the cold face. I'm starting to see people break down those stereotypes of robots are going to steal everyone's bloody jobs. The biggest change is people are really understanding what they are, even if it's just a robot that vacuums the floor. People are having that less fear of what's coming on. And contact-free food is going to be the next gluten-free. That's my prediction. So robots serving food. Anyway, lots more to come.
Thank you. And Camilo, last comment from you. What's the big thing in robotics?
I think the biggest thing, and maybe people haven't realized quite yet, is that I think with ROS2 being able to run on anything from microcontrollers, like you said earlier, and any device, a lot of the computation that is needed on big robots today, with more CPU, GPU, etc., will be offloaded to the cloud. So I think the possibilities of what is going to be built in the next 5 years, I think is going to be very different than what we built today. And I think we haven't quite realized that, how much you can offload to the cloud.
Well put. And thank you all for a really active discussion. Very great questions too. And I've really enjoyed it. And yeah, thanks for staying the extra time and making it happen. And good night, everybody.
Thank you so much. Good day, everyone.
Have a good one, everyone.